Assalamu alaikum students. Welcome to Physics Academy KPK. I hope you're all doing well. In today's video, we are kicking off our journey into the fascinating world of physics with Chapter 1, which is all about physical quantities and measurement. We'll start with the very basics. What is physics? What are its main branches? And what do we mean by physical quantities? So grab your notebooks, get comfortable, and let's dive right in. So, what exactly is physics? In simple terms, physics is the branch of science that studies matter, energy, and the relationship between them. Everything around us, from the apple falling from a tree that inspired Newton, to the planets orbiting the sun, and even the tiny light bulb glowing in your room, is governed by the laws of physics. It's the science that helps us understand how our entire universe works, from the smallest subatomic particles to the largest, most distant galaxies. It's truly the fundamental science of how things work. Now, because physics covers such a vast range of topics, it's divided into several specialized branches. Think of it like a big tree with many limbs. First, we have mechanics, which is all about the motion of objects, why they move, and what happens when they collide. Then there's thermodynamics, which deals with heat, temperature, and energy. Next up is optics, the study of light and its properties, which is why we can see things. We also have electromagnetism, which explores the connection between electricity and magnetism, the force behind motors and generators. For the very small stuff, there's nuclear physics, which studies the nucleus of an atom. And for the very big stuff, we have astrophysics, which looks at stars, planets, and the universe as a whole. Each branch unlocks a different secret of our world. Okay, let's move on to a key concept: physical quantities. What are they? A physical quantity is simply anything that can be measured. If you can put a number to it, it's a physical quantity. For example, you can measure the length of a room, the mass of a book, the time it takes to run a race, or the temperature outside. Every single physical quantity has two parts: a numerical value and a unit. For instance, if I say the length of this table is 2 meters, 2 is the numerical value and meter is the unit. Without the unit, the number 2 is meaningless. Is it 2 centimeters, 2 kilometers? The unit gives the number its physical meaning. Now, these physical quantities are sorted into two main types. It's a simple but very important distinction. We have base quantities and derived quantities. Think of base quantities as the fundamental building blocks. The ingredients, derived quantities, on the other hand, are created by combining these base quantities, like a recipe. Let's look at each one more closely. So, what are these fundamental building blocks? The base quantities. In the International System of Units, or SI, there are 7 of them. These are considered the foundation of all other quantities. They are length, which is measured in meters, meter mass, measured in kilograms, kilogram. Time measured in seconds, S. Temperature measured in Kelvin, K. Electric current measured in amperes, A. the amount of a substance measured in moles mole, and finally luminous intensity, which is measured in candelas CD. You absolutely need to memorize these 7 base quantities and their SI units, as they are the alphabet of physics. Now that we know the base quantities, let's talk about derived quantities. As the name suggests, these are derived or created by multiplying or dividing the base quantities. They aren't fundamental on their own. Let's take a few common examples. Area is a derived quantity. To find the area of a rectangle, you multiply its length by its width. Since both length and width are measured in meters, the unit for area becomes meters squared square meter. Another one is speed. Speed is the distance traveled divided by the time taken. Distance is a length meters and time is in seconds, so the unit for speed is meters per second, meter per second. A third example is force. From Newton's second law, force equals mass times acceleration, giving us a unit of kilogram meters per second squared, kg meter per second squared. See how they're all built from our 7 base units. Alright, let's do a quick recap of what we've learned today. We started by defining physics as the study of matter, energy, and their interactions. We then explored some of its major branches, like mechanics, thermodynamics, and optics. After that, we defined physical quantities as anything that can be measured, and we learned that they are divided into 2 types: the 7 fundamental base quantities and the countless derived quantities that are created from them. And that's our introduction to Chapter 1. I hope this session was clear and helpful. If you found this video useful, please give it a thumbs up. Subscribe to Physics Academy KPK and don't forget to hit the notification bell so you don't miss our next lesson. Feel free to share it with your friends and classmates too. In our next video, we'll get hands-on and learn about important measurement tools like the vernier caliper and the screw gauge. Thanks for watching, and see you in the next one.